Hi everyone. Today we will talk about the protection of the electrical systems. We will talk about the importance of this protection, what we are interested about these concepts, and what are the main components of the protection system. Okay, the first concept that we have to understand is protective relaying. What is protective relaying? It's the concept of protection that is set up for our electrical systems in order to first detecting the abnormal conditions and initiating a corrective action, then returning the system to normal state quickly. So the purpose of our protective relaying consists of detecting the abnormal conditions. What does it mean? Of course, each or any protection system consists of detecting the fault that may occur, the problem that we may have, and the solution. So in our case, the problem is the fault. It's called fault in our electrical system terms, and the fault consists of abnormal conditions. What may be these abnormal conditions? The change of voltage or the change of currents. So as overall the change of power, and maybe the change of temperature also, because of course the change of temperature will lead to the circulation of huge amount of current, and this will lead to a fault. So after we detected the abnormal conditions, we have to initiate a corrective action. We have to initiate a corrective action, and this may be done with a circuit called trap circuit that we will explain later. Okay, so first purpose is to detect the fault and correct it, and not also correcting the fault, but also we have the aim to return the system to its normal state quickly, also because as it's important to have the first state of the system before the occurrence of the fault, we have to return it quickly, because as time as we take, we will have negative effects of this fault, and I will explain this later. So when a fault is occurred, we should have a response. So what are the, we can say, best characteristics of the response? This response, what are the characteristics that this response should have in order to say that this protective system is working in appropriate way? The first one is that the response should be automatic, of course. And in these days, we will not set a human interaction for each part of the system. Will lead a very bad efficiency of the interaction, and correcting the fault as will take a very very long time, and will not be accurate as the automatic response. So this response should be automatic, and the second one is a quick response. Of course, we have to uh, have a quick response, because if we don't have this quick response, and let's say that the protection is done through 10 times the time needed. In this case, we During the fault, we have the sudden voltage drop of the voltage from its own value to zero. So when we have this sudden voltage drop, we may lose the synchronization between the system and with the generators. So this may lead to a disaster that is called blackout. So of course, a quick response is a very important characteristics of the protection system. The third point is a minimal disturbance. A minimal disturbance, of course, it's important for us to detect the fault and interact with corrective actions, of course, and return to our normal state quickly. But of course, we are trying to prevent any negative effects of these faults. Okay, so as we understood here that this operation is done with a circuit that's called trap circuit, and this is a trap circuit blocks. The first component is a current transformer. Because we are using a current transformer, basically these systems has a very big amount of current, so we can't connect the second. Our element here is a relay. The relay, we will explain later what is it, but should be as a sensor. It acts as a sensor that sense the fault and gives alarm. So let's define it now as a sensor that senses the fault and gives alarm. So this protection or these electrical components can't be supplied with a huge amount of currents. So in this case, we can use a current transformer in order to reduce the amount of current with a small scale. Okay, so after reducing the current, we will go to the relay. The relay will sense that there is a current, there is a variation of the current, so we'll sense and give alarm as an alarm to the protection component. The main protection component in our system here is the circuit breaker. Okay, so when receives the alarm, a signal from the relay, the circuit breaker will interact with the system in order to open the circuit, for example. So our operation consists of fault occurrence. The fault occurs at the first, and then at the end we have a conclusion is the circuit breaker clears. Okay. So now let's define what is the relay. The relay, in simple way, is a electrical device with electrical component that receives electrical signals as a variation of voltage or current, so with work together in order to gives a signal based on this variation. But in our system, we are talking about a very detailed concept of the relay that's called the protective relay. What is a protective relay? Is a relay that is connected in the circuit, in our electrical components, that interacts, that gives alarm, gives signal, okay, based on predetermined value, predetermined value of current, and then when this value, when the protective relay detects this value, the protective relay will give a signal to the circuit breaker component. So this is a trap circuit, as we explained first. Here, maybe the circuit is not clear. I will explain how can work. In fact, we have as a first element the electrical system, okay, and then um, when the electrical system cause a current that it's not normal current, the relay will sense this change of current and will give a will create a short circuit. But in this short circuit, we have to have a battery, okay, and this battery will lead a generation of the current, okay, and this current will lead to we can say magnetic change in order to trigger the circuit breaker to prevent the error, okay. And as an important definition here, we can say the peak up. What is this peak up? It's a value operating quantity. It's a threshold value of operating quantity. With it is a minimum value. With it, the protective relay can trigger a signal. So our system consists of this timeline presentation, as we have first the occurrence of the fault, then the time taken from the prevention of the fault, so detecting the fault occurrence, and as till the response of the relay, this time is called relay time. And then we can have the time that starts from the signal of the relay until the circuit breaker interact with the system. This time here is called circuit breaker time, and then we can have the entire operation called fault clearance time. So there's a real relay time with the circuit breaker time. I'm sorry, because the circuit breaker time is taken from here, okay, to the end of the operation. So relay contacts close is a small amount of time that belongs to the circuit breaker time, okay. And of course this time is measured in milliseconds, and as other language or other phase of the measurement can be measured in cycles. I hope that I um, was able to explain this basic concept in clear way. Thanks for watching, and see you later.